Hi, welcome to Ethereal Mechanics, Electrogravity, Gravity. In this video, we're going to have a discussion about the topics relating to gravity. This is the fourth video in the Ethereal Mechanics, Electrogravity series. Okay, the topics relating to gravity are the speed of pretons, a model of matter, because a model of matter is what reacts to gravity and what generates gravity. We're going to talk about inertial feeding. We're going to talk about the small-scale gravity model. We're going to derive the constant g. We're going to show how the inertia of matter manifests itself. This is what scientists used to call mass. And we're going to talk about a phenomenon called process dilation, which physicists used to call time dilation. And at the very end, as a bonus, we're going to show you a preliminary cut of the ethereal mechanics standard model. And right after that, we're going to have a little discussion about how faster-than-light starships are going to work, at least the initial artist conception. So what we talked about previously, that pretons cannot move faster than the speed of light. Otherwise, they're going to intersect their own inertial field, which will cause them to react in the opposite direction. But then the question is, can pretons move slower? Well, theoretically, if a preton is not under force from like being inside of a system of matter, because under a system of matter it's under continual force, and if it's not under the influence of some distant pretonic radiation, then if it's not under any kind of force and it's in a viscous medium like the ether, then a preton has no inertia, then theoretically a preton should come to an immediate halt within the medium. Okay, and these pretons that are free of any forcing functions, we're going to call them free pretons, or freetons for short. Now theoretically, as long as these freetons move with the medium, they move and accelerate with the medium, then they will not generate any radiation and they'll be completely inert. Okay, but the problem happens is if they eventually come and strike something, just like a ship would strike the bioluminescent algae, it disturbs the algae, and the algae produces a bioluminescent signature. Or when the algae crashes along the seashore, it also creates a bioluminescent signature. And so likewise, if these freetons are minding their own business and they fall into a gravity well and all of a sudden hit the ground, then they're going to cause some kind of energy signature. Or if they're sitting in free space and George Jetson hits them with his spaceship, they should also cause some kind of energy signature. But right now, the theory is that freetons should be almost non-existent, because the minute they're created, they should fall right into the gravity well of the object that created them, and they should be reabsorbed. So I do not think that these are there in significant numbers. But we need to discuss them because they are a possibility. Maybe these are part of the cosmic waves we see, or cosmic rays that we see impacting our detectors on the Earth. Okay, but we're going to talk about, for the majority, for the rest of this paper, we're going to talk about pretons under force. Pretons that are part of a model of matter are under continual force. Now here's a conundrum that bothered me for many, 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 many years. Because under Newton's model here, force is equal to inertia times acceleration. So if something has no inertia, pretons have no inertia, then we're trying to compute how pretons accelerate. Well, you got force divided by zero inertia, which results in a singularity. And I do not believe in singularities. All apologies to Mr. Einstein there. Singularities just means you ain't got your math right. So how can we talk about pretonic force when pretons have no inertia? And that bothered me, but I finally came across a solution to this. And what we need to do is we need to update physics once again. And what I found out is F equals ma is a very simplistic thing for very low velocity systems, for what we say non-transvariant systems, which we would say, used to say, non-relativistic systems. Once you get to high speed transvariant systems, then you have to have a mediation of this equation, just like you have time dilation and you have other types of dilations of physics when things acquire high speed. So we're going to introduce in another paper a new transvariation called force dilation. Or we may call it force transvariation. I don't know, but this is going to be a mediation of force due to things moving at high speeds. Now let me show you an example of force dilation. If we look at this surfer, we have this forcing function. This forcing function has a limited velocity. Okay, so you can't just take the force of this wave and divide it by the inertia or mass of the surfer and figure out what her velocity or acceleration is going to be, because she's going to absorb a little bit of the force, a tiny little bit of the force or energy of this wave, and get up to speed to the point where she's going to be scooting ahead of the majority of the energy of this wave. Okay, and therefore there's an issue here because she's traveling ahead of the bulk of the energy of the wave. She is not going to couple the full force of the wave. And that's what happens to pretons. And we can show this again with a much, much bigger wave. Okay, again, the amount of energy that this surfer is going to pull from the wave is going to be the same amount of energy no matter how big the wave is. He just needs a little bit of energy to get going to the point where he can now scoot ahead of the wave, and he's traveling at the speed of the wave. And therefore, because in ethereal mechanics, all forces are transferred by radiation, it is possible for particles to move ahead of the radiation so they do not fully couple the radiation. So this insignificant is the inertia of this surfer to the wave. That because of that, we can just say if something has insignificant inertia, it's just going to be at the speed of the wave. Okay, so this force dilation discussion is going to go for a complete derivation and a supplement to the transvariance once we fully unpack it, and it will be part of the mechanism of length contraction. For now, what we're going to say is that pretons that are part of a stable system of pretons will always travel at the speed of light in the direction of the applied acceleration. And that's how we're going to get by this for now until we get the full force dilation of transvariance unpacked. So now let's talk about matter. So what we have here is we find an interesting thing happens if we put two like pretons in a system where they orbit about a central point at the speed of light. Both the magnetic force and the inertial forces cancel, and this system becomes stable. And we call this system a second order system of pretons. Second order because velocity is the first order derivative of position, and acceleration is the second order derivative of position. So this is a second order system of pretons, a SOSOP for short. Now what we can do is we can use the inertial force and compute the inertia. If we try to accelerate this system, if you try to push this along with your fingertip, by accelerating this preton, this guy is going to have a reactionary force against your finger. And likewise, if you push this one, this guy is going to give you a reactionary force. And that's given by the inertial force equation here. So if we want to compute the complete and reactionary force to you trying to accelerate this system, it is twice the inertial force. And this is 2 times. This is the charge of each of the pretons divided by the distance between them. And that's the inertial force that you're going to feel. And because force is F equals ma, then the inertia B is equal to twice, because the preton charges are the same, twice charge preton squared divided by the distance between them. Or if you want to say, well, the radius of the system, which is half the distance, then the inertia is just the preton charge squared divided by the distance, the radius of the system, the radius of the orbital radius of the system, RO. And so if we punch into this inertia, and what our standard model of the electron is that the pretonic charge of negative pretons is half of the charge of an electron, and the distance between the charges is half the classical electron radius. I know this says radius. It really should have been distance, but they got it off by a factor of 2 anyway, so it doesn't matter. So if you put these values into this equation, you're going to come out with this amount of Bourles, and you'd multiply Bourles times km. That converts Bourles to kilograms, and that is the mass of an electron in kilograms. And the important thing about this is that the mass of a particle or the inertia of a particle, is a state of the system. It's not an intrinsic property of matter. And another important thing is that the inertia of a particle is inversely proportional to its size. And we can see this if we look at the lower three particles of the leptons, the electron, muon, and the tau particle. They are the same system, just orbiting at different distances. That's all. They're exactly the same particle. And here we show that energy and inertia are very highly correlated quantities. So when a system absorbs energy, it gets shot into a higher energy state system where it has higher inertia. So energy and inertia are not interchangeable according to E equals mc squared. Energy and inertia are correlated. Okay, and also when more inertia does not mean more stuff was created from nothing. In each one of these systems, even though this has higher energy and higher inertia, there is not more stuff here. Because when you look at this on other places, they show that these particles are larger because they have higher masses. That is completely backwards. This is a smaller particle and an ever smaller particle still. Now let's talk about gravity. Again, we have the second order system of pretons. And because both the inertial force and the magnetic force cancel, we have two forces that cancel. And what we learned, what we theorized way back in video EM03 is that in order for Mother Nature to apply a force, she has to suck in ether. You cannot apply a force without consuming fuel. This is the force-fuel paradigm. Although we've known about this for a long time, it wasn't until recently that it got unpacked properly and put into a proper perspective that we're going to show you now. So, stable matter is two forces in balance, and we can determine how one force. So, if we can determine how one force feeds, then the other force should feed at the same rate, even if we don't know what the other force is or how the other force feeds yet. So, what we do now know is how the inertial force feeds. But the problem is, because we don't know how ether stores or transfers energy, we're going to use a simple abstraction where the energy content is a function of the volume of ether. And this works out to a very simple feeding model right now. So the inertial force feeds at a rate that's proportional to the acceleration of a preton times the cross-sectional area of a preton, which works out to volume of ether consumed per square second. Now, this has amazing ramifications that we're going to unpack in a new paper called the New Energy Paradigm paper. I was going to try to unpack this in the electrogravity paper, but this just blossomed into a whole bunch of rabbit holes, so I needed to move the unpacking of what this means into a whole new paper. So right now, this is the proper feeding rate for a preton. This is the acceleration of a preton under centripetal acceleration, and this is the orbital radius of the system. This is the acceleration. Okay, and because there's two pretons that are feeding, we're going to go 2 times the feeding model. But now, to account for the balancing force, the magnetic force, which balances the inertial force, we're just going to multiply this by 2, because we haven't quite figured out how the magnetic force feeds yet. But that will be a part of the new energy paradigm paper, which is a follow-on paper. Okay, this I'm very sure about right now. Okay, so now what we need to do is say, well, okay, this is how ether is fed. But now we want to turn this into, well, what is the acceleration of ether at a distance d from the center of rotation? Well, all we have to do is take this feeding volume and divide by the surface area of a sphere. And that actually gives us the acceleration of the ether going inward in terms of meters per second squared. That's the acceleration of the ether toward a massive body. Okay, now this is just this simplified. So this is actually our gravity model for ethereal mechanics. This is our gravity model. because gravity is the acceleration of ether toward a massive body. So this is our gravity model in terms of ethereal acceleration relative to a massive body. So next what we're going to do is we want to look at Newton's gravity model, because we can take Newton's gravity model, and the blue shows that these are legacy values. Okay, and so if we divide both sides by the mass that exists at some distance, we get the acceleration. And this acceleration is also identical to the acceleration relative to a massive body, but this is now defined in terms of legacy constants. Okay, so what we're doing here is we're just getting rid of the vector components. So we just have a quantity, acceleration as a directionless quantity. So we can assign this equal to our other model, which we developed without concept for vector, but that's fine. We did that in the paper. So now we're setting the legacy acceleration equal to the new ethereal mechanics acceleration, because they're equal. And then what we did down here, now we went all the way down. I'm not going to go through the steps. I do the steps side by side. So this, you substitute this into this to get this. You substitute these into that to get this. So this is how we derive G from ethereal mechanics constants. Now note, there's a mistake in the version 0.5 draft of electrogravity that's fixed in the version 1.0, which is released under Stinty now. The previous videos have an incorrect value for G posted. That's okay. It's only off by a factor of 2. I forgot to multiply by 2 for the balancing force. Sorry about that. Okay, now, but let's take this one step further. Okay, and we're going to substitute the charge of a proton, because we know the charge of a proton is half the electron charge. Okay, so that gets rid of the charge of a proton and puts in a known value here. Okay, and now what we can do here is we can actually solve for the cross-sectional area of a proton. And that's how we're probably going to keep this, because right now we're not sure if a proton is a sphere or it's some other structure. This will cover it either way. But right now, let's do what we did in the paper and assume that proton is spherical. And we can say that the area of a proton is pi times the radius of a proton squared. Substitute this in. And now this is our new value. This is how the value should have appeared in all the previous videos. I believe it has an 8 here instead of a 16. Slight mistake. Okay, but now we solve for the radius of a proton. These values on the right are all known values. Unit charge, the magnetic field constant, the constant G, 16 pi, the speed of light squared. So what is the radius of a proton? Proper radius, now this is corrected from the previous videos, is 6.9 times 10 to the minus 37 meters. I did a calculation that if you took all of the visible matter in a galaxy and reduced it down and packed the protons edge to edge to edge to edge, all the protons of that entire galaxy would fit inside the candy shell of an M&M with space left over. So I hope I did the calculation right. I'm human. I do make mistakes. I'm not a physicist. I do make mistakes. Okay, the last topic we're going to talk about is process dilation. In our model of matter, we said that the protons can never move faster than the speed of light. So what if this system were translating up out of the page at some velocity v? And so what's going to happen to the rotational velocity? Well, right now the rotational velocity is equal to c, and this is the rotational velocity when the system is at rest. But now if the system were propagating up out of the page, traveling up out of the page, and this is the side view, so this system is now traveling up with some kind of velocity v, well, the sum total velocity of the protons can't be faster than c, and therefore the rotational velocity and the translational velocity can't be more than c. And therefore, if we solve this and solve this, we can solve for what is the rotational velocity under translation. That's what that little prime means, is going to be c squared minus v squared. Now, if we take the ratio of the rotational velocity under translation to the rotational velocity at rest, we get this quantity, which works out to what scientists used to call the time dilation equation. This is not dilation. Time does not dilate. Matter slows down. The fundamental processes of matter slows down. Okay, we call this now process dilation or process transvariance. Okay, We don't say relativistic anymore. We say transvariant. Because relativistic, well, I'm not going to go down that road. So here's where I'm going to cut in the begging and pleading for all of the people that are not Patreon members. So the Patreon members do not have to sit through my begging and pleading. So here is the standard model of science. Now, because all of these items over here represent interactions and force carriers, but we know protonic fields and ether are the force carriers. So we can eliminate those. Okay, and I showed you before that the electron, muon, and tau are just different states of the electron, or the same particle. And that's true for all of these going up and down the chain. So these are really the only unique particles that they see coming out of a particle accelerator. But it's even simpler than that because they are just combinations of positive and negative pretons. Okay, and so I'm very sure right now that negative pretons are made of half charges and positive pretons are made of 6 charges. Okay, and the up quark has the most mass. Well, no, let me rephrase that. The up quark has more mass than the electron, and that's because these are a very tiny radius of orbit for these guys, and that gives them more mass. Again, they show you all these particles that something that has more mass is a bigger particle. Again, completely backwards. Okay, in ethereal mechanics, the closer together your pretons are, the more inertia it has, what they used to call mass. Okay, and so I'm not sure about the arrangement of these guys here. It could be that there's a much more complicated way they orbit about each other. Not sure yet, but you can see from these combinations that there are other possible combinations that might exist that they don't account for. Okay, I'm not going to get into that right now. But anyway, the sizes are not to scale. So now let's talk about faster than light starships. What I've talked about in this video is that pretons cannot go faster than light relative to the medium. So in order to get a starship to go faster than light, we're going to have to drag the ether with us. Just like in a jet aircraft, the cabin drags the air with it so that the passengers are not under the effect of 600-mile-per-hour winds or bone-chilling cold or very low pressure where there's not enough oxygen to breathe. We're going to have to do the same thing. And what I'm going to do for my Patreon folks is I'm going to have a separate video where we're going to look at some interesting physical phenomenon that may actually be useful in creating a faster than light bubble to pull humans through space. Thank you very much.